This conference will now be recorded.
See, UVM training is divided into two aspects. One is the essentials and one is advanced training. So for most of our requirements, essentials would be sufficient. So overall training is 8 weeks, 8 to 9 weeks. And out of this, Group Sagar, please be in mute. Okay. Initial 4 to 5 weeks will be on UVM essentials, and another 4 to 5 weeks on UVM advanced. For all the fresher requirements, even for some of the working professional requirements, this would be sufficient. This would cover some advanced aspects. So we will talk about all those things today, what will be covered as part of advanced and what is covered as part of essentials. So that's what I have explained here. Okay. So this is what is covered in the essentials. What is UVM? We start off with understanding what is UVM, why we need a methodology, the UVM methodology overview, some basic concepts of object-oriented programming. Then how do we develop a UVM test bench architecture? The concept of phases in UVM, common phases and scheduled phases. Then we talk about the base classes, root, command line processor, reporting classes, factory, config DB, resource DB, all these things. When you go to the advanced topic, it would be little advanced topics like sequence library, various styles of sequence coding, advanced sequence methods, the TLM 2.0, the synchronization classes like event and barrier, policy classes, the pools, the phase jumping, register layer classes, the callbacks, comparator, heartbeat, report catcher, register model development. All this will be covered in the advanced aspect of the UVM. The schedule wise, these topics kind of gets divided. So it's like this gets covered in 1 week, this gets covered in the second week. Roughly you can do that kind of division, 3 weeks, the 4th week and the 5th week kind of thing. There might be plus or minus 1 week, but this how roughly it gets distributed. This is where I have written that distribution. So this is a quick overview of UVM training and the schedule. So before I get into the UVM topic, do you have any questions? Okay. Okay. So first of all, before learning UVM, we need to understand that yes, someone is asking a question. UVM is important for SP students. Yes, it is very important because a lot of job requirements are based on UVM. Next. First of all, before we start with UVM, we need to keep in mind that UVM is actually easy. Why it is easy is, I mean, it makes UVM is a set of guidelines which makes whole test bench development process lot easier. So now if I ask you, many of you have completed system Verilog training, language training. If I ask you, given a design, I give a design, let's say it can be simple thing like asynchronous FIFO or a complex design, let's say PCI controller. setting up Testbench using Verilog. Second option is setting up Testbench using System Verilog. Which one is easier in terms of the developing test cases, in terms of developing various components? Which one is easier? Doing it using Verilog is easier, or so System Verilog is lot easier. Because why is it easier? It comes with lot of constructs. Like constructs means what? Mailbox, event, semaphore, etc. So many things are there. Even most importantly, what is most importantly? Object oriented programming concept, which makes test bench development lot easier. What is the only effort? What was the effort with, what is the drawback with Verilog? The drawback with System Verilog? We need to spend time to learn System Verilog. Once you have learned it, this is much easier compared to this one. So the only effort is about learning that new language, and using that new language is the only effort. Otherwise, this is always lot easier compared to this aspect. Same thing is with UVM also. Let's say now we move on to setting up test bench with UVM. How I can tell you is, I mean, how do we understand this is, if a project duration is for, let's say, if a project duration is for, let's take only PCI controller, 6 months. This will take probably 6 months to complete the project. I think now the duration won't be required here. This will take System Verilog, using System Verilog may take only 4.5 months to complete. Not complete. This will take only 3.5 months to complete the project. See, what happened is, when you moved from Verilog to System Verilog, it reduced the time by some amount. Instead of using System Verilog, if you use UVM, it will further reduce the time, and without compromising on the quality of verification. Even though we take less time in setting up test bench and completing verification and complete verification and completing verification, we won't compromise on the verification quality. We won't compromise on verification quality. We will still have the same quality of verification. Is it clear how it will help? Now the question comes, what is that it has got to reduce the time taken? I mean, how is that we are able to do it? How is that we are able to reduce the time? Let's say, what is, when we are moving from Verilog to System Verilog to System Verilog, how the time comes down? I mean, how time is coming down to 4.5 months? Can you tell me what is that is contributing?
So many constructs and available in System Verilog that are not available in Verilog.
Anyone, can someone else also add on?
Everything is almost defined in UVM.
Yeah. So we are talking about Verilog to System Verilog. Basically, System Verilog has a lot of new concepts.
Randomization.
Object oriented programming, everything I have listed here already. All those makes it easy to set up test bench, develop test case development, Please be in mute. Syed, please be in mute. Development. Now, when we move from system Verilog to UVM, it further comes down. Let's say it may take 3.5 months. It's roughly, I mean, not exact always. What happens is UVM provides with predefined base classes, which can be used to set up the test bench easily. So user don't have to develop test bench from scratch. That's the baseline. I mean, this is what is helping us reduce the time taken to develop the test bench. User don't have to develop test bench from scratch. The UVM provides with a predefined base classes, which can be used to set up the test bench easily. Now, let us understand what is meant by predefined. What are these predefined classes? To understand this, let us take two designs. We'll take two different designs. One is, let's say, keyboard controller. One is SPI controller. We'll take two designs. One is keyboard controller, one is SPI controller. Let us set up a test bench architecture for them. Let's develop test bench architecture for them. I'll take paint and I'll draw there. Can everyone, let's say if I have a keyboard controller here, this is my keyboard controller. Let's say it has got one interface here, which is APP interface. I have another interface here, which is keyboard specific interface. Let's say I call it as keyboard interface. Can you take 5 minutes and develop the complete test bench architecture for this, everyone? You take any language, doesn't matter, Verilog, system Verilog or UVM. Can you please come up with a test bench architecture for this? Hello everyone. I'm sorry for the break, long break. So I hope you have developed the test bench for this. So if you see, the test bench architecture will consist various components like the BFM, generator, monitor, coverage, reference model and register model, another monitor, slave model and checker and scoreboard. Here you have assertion. All these are connected using mailboxes. There's a mailbox through which you connect these things. Mailbox. Again, this is connected to mailbox. You can see that this component is called as what? BFM. This is called as generator. This is called as coverage block. This is monitor. This is a reference model. This is register model. This is checker. This is scoreboard. And this is again a monitor. This is slave model. These are assertions. Assertion. This is how the test bench architecture looks like. Now, if I tell you one thing, if I replace this instead of this, if I use here, let's say instead of this, if I have SPI controller, for example, SPI controller, do you think my test bench architecture will differ? Do you think will there be any big difference in the test bench architecture?
No, sir.
No, sir. Basic building blocks will be same.
Almost everything will be same except for some functionality we need to be changed in the generator. Because assuming that even SPI will have APB, here it will become SPI interface. So I have to use SPI slave here. Use SPI slave model. Other than that, lot of things are same. This is what UVM exactly uses. So UVM uses the concept that any design you take, any design test bench, basically, or rather I will say all design test benches have lot of things in common. All design test benches have lot of things in common. Common means what? The way you code generator, the way you code BFM, the way you code monitor, coverage, everything. There are a lot of things which are in common. So UVM basically implements all those common things as UVM basically. And when user develops test bench, so user don't need to code everything from scratch. User don't need to develop everything from scratch. User can inherit, what do you say? Inherit, extend the base class and implement the additional functionality. This is all user has to do. See, understand the concept. When user develop the test bench, user don't need to code everything from scratch. Extend the base classes and implement the additional functionality. In this context, let's say if I'm developing test bench for keyboard controller, the BFM for keyboard controller and the BFM for SPA controller, actually speaking, they won't differ at all. They have a lot of things in common, because if it is APB, they will be same. Only thing that differ, what UVM provides me is for developing UVM APB BFM, it is called as APB driver in UVM. What user has to do is, user has to write class APB driver, extend UVM driver. So the UVM driver is the base class provided as part of UVM package. What is UVM driver? It is the base class provided as part of UVM package. User just need to extend that UVM driver and implement the functionality specific to APB protocol. Okay. So where is that we are started all this discussion with? We are trying to understand what is there in UVM, what is that UVM have, which is bringing it on the time. Initially, it was taking me 4.5 months to do everything using system Verilog. When I'm moving from system Verilog to UVM, my overall time to complete the verification is coming down to 3.5 months. So what is it making it happen? So there we understood that the first important thing is a commonality in all the test benches. Basically, commonality, all test benches have a lot of things in common. That's the first thing. Next, all test bench components also have a lot of things in common. It means to say, example, if I'm developing APB driver.sv and AHB AXI driver.sv, both these components have things in common and also things which differ, There are things which are common, also things in which they differ. So now what we will do is we'll try to understand what is common between APB driver and AXI driver. If you take this component, I'll call this as, technically I'll call this as what? Driver. I'll call it as driver. Because when we move to UVM terminology, things will differ. Let's see how the terminology differs. So the terminology difference. The generator in system Verilog. So this is system Verilog terminology. I'm going to write here UVM terminology. Generator becomes sequencer. BFM becomes driver. The sub-environment becomes agent. Mailbox is replaced with something called as transaction level modeling. Reference model is replaced with scoreboard. The transaction is called as item. The transaction is called as item. These are the terminology difference. I mean, if you are used to system Verilog terminology, when you go to UVM, you have to use this terminology. Oh. So now let us get back to this topic. The APB driver.sp, AXI driver.sp, both these components have things in common, also things which they differ. Now let us talk about what is that common. What is common for them? Tell me. You see this architecture? In this side, you see this architecture. Can you tell me what do you think is common here? For a driver, had it been AXI driver, and assume that it is APB driver. So what is common for both the drivers?
Clock signals, reset signals, like these signals will be common.
First thing common is both are connected to generator on one side. Simple, right? Simple observation. In both the cases, both are connected to sequencer. I will call it as sequencer. What is the other thing that is common for both of them?
Interface connected to the interface other side.
Yeah, both are connected to DUT using interface on the other side. Can I say that? Is that correct?
Yes.
Next. What else is common? Both get transactions from transactions or items. I told you, right? Transaction becomes item in UVM from sequencer, and which is driven to the DUT. They call drive item task to drive the transaction to the DUT, and both get the response from DUT. Can you please read this once? Do you see there are a lot of things that are in common for both AXI driver and APB driver. Now let us understand where do they differ. What are the things they differ? What is difference for them in them? One only difference is what do you think is the difference between APB driver and AXI driver?
TLM ports.
Basically, APB driver implements APB protocol for driving purpose, transaction driving. AXI driver implements AXI protocol for transaction driving. So that is where they only differ in terms of the drive transaction code only differs. Otherwise, you see both of them are exactly same. Do you agree with that? Both of them are exactly same except for one drive transaction code. That is what exactly UVM uses. So what UVM does is it tries to implement all these things as part of the base class. See, whatever is common for all the drivers, You take APB driver, you take AXA driver, you take AHB driver, whatever is common for all these things, it implements all of them. It implements all the common things in the base class. So whatever is common, so this is implemented in all these are implemented in UVM driver.sv file. Now when user does class APB driver extends UVM driver, what happens is all above common things, all above 4 common things become part of my class, become part of APB driver. User needs to only implement the drive transaction specific to APB protocol. Did you understood? Please read this once. In meantime, I'm sorry to interrupt. Nitesh, you have joined. Can you please share your mobile number? I have messaged you every day. I keep asking you, where are you from? Can you please message me your phone number? Everyone, my request, please do not share the regular session links to everyone. I mean, you don't put it in groups. Okay, if you want to help your friends, help in some other way. Okay, not by sharing the links. If someone has registered, only then they will attend the session. Those who have not registered should not be attending the sessions. Okay, today is demo session. I'm talking about this person Nitesh keeps attending every day, and we don't have any person by name Nitesh in our batch. Okay. Yeah, Nitesh, can you please share your phone number? Nitesh, can you hear me? Okay. So I hope you understood that. Whatever whatever is common to all the things, they will be part of UVM driver. User needs to only implement the drive transaction specific to APB protocol. Now, what about interface class with respect to UVM? Chetan, can you be more clear with what is interface class? You are talking about interface, interface, is it?
Yeah, interface.
Of course, that need to be done. See, here I have to write virtual APB interface VIF. In AXI, I have to write AXI interface. There will be some differences. It's not like just automatically everything will happen. What is that happening is a lot of things that are common between all the drivers are implemented into UVM driver. The only thing they are going to do here is they are going to use the parameter as APB transaction. Two things they will do. They will extend it from UVM driver. They will use APB transaction here. So what happens is the UVM driver gets updated. UVM driver gets updated for handling APB transaction. UVM driver gets updated for handling APB driver, handling the APB transactions. So any questions so far regarding this? Okay. You will get more clarity about this when we develop some test bench environment. As of now, we are trying to understand what is the benefits of UVM. So that is where we discuss that. The first thing is every test bench you develop, there are a lot of things in common. The UVM takes advantage of that common things. Means when you develop any test bench, can everyone hear me? Okay. When you develop any test bench, my reference model will always be in the same position. My reference model will always be in the same position. It won't sit here. My generator won't go to some other place. So this is what UVM tries to take advantage of. What UVM does is, in summary, is the people who have developed, UVM has made observations about what is common in every test bench. Every test bench, you take any test bench, what is common? They have implemented all those common things as base classes, UVM base classes. So user has to use these base classes and create the required class, required component. I will tell you, if I will give you one example how this becomes so easy is, if you have to develop sequencer in UVM, to develop APB sequencer. Okay, that is nothing but APB generator. Code is very straightforward. All we have to do is class, very simple, type def UVM sequencer hash APB transaction APB sequencer. That's all. This one line what I coded, line number 90, is the code for this complete generator.
Any purpose of type def here?
Why we are using type def is, using this we are creating a class, we are creating a data type. We are creating a data type by name APB sequencer, which is nothing but UVM sequencer parameterized for APB transaction. What you are doing is, UVM is providing us UVM underscore sequencer. When we parameterize it for APB transaction, it gives us APB sequencer behavior. That is what I have done. Type def is used to define a data type. Even if I have to develop, let's say if I have to develop AXI sequencer, tell me what should I do? Can you tell me? Tell me, what is the only change I have to do in this case? To develop AXI sequencer, that is nothing but AXI generator, what should I do? Go and change it to AXI.
AXI sequence.
That's all. Now you may be thinking, how can it be? One second. It is that UVM sequencer has everything implemented in it. UVM sequencer has everything implemented into it. So user don't have to do anything. Everything is part of it. User just has to customize it for APB requirement. Customize this for AXI requirement. Yeah, please ask now.
Yeah, question that, like in APB generator, we had those run tasks, all those things, and we used to generate those packets, and we used to send to the other guy, correct? All those things.
Yeah.
Now that is in sequencer.
No, there won't be in sequencer. What UVM does is, it separates that into two parts basically. What it does is, it creates something called as sequences. UVM separates the transaction generation and the generator into two different entities. One is called as transaction generation, is called as transaction generation. That sequence is called as sequence. The generator is called as sequencer. So whatever you said right now regarding generation of a sequence and all that, that will go into a sequence file. That will go into a sequence file. The remaining thing will be generator code.
Okay, not just it is nothing but an like placeholder for the sequences.
Yes, yes.
Okay.
Because of that division only, we are able to do it so simply. If transaction generation was part of the sequencer, then we couldn't have done it so easily. Because then the functionality will come into picture, right? We have to generate a sequence specific to APB, then we have to generate a sequence specific to AXI. So my sequencer wouldn't have been so straightforward. Now, because of that, my sequencer coding is only one line effort here also. Now, so it all comes down to line number 85. What is that? So people who developed UVM has made observations about what is common in every test bench. What they have done is they have implemented all these common things as UVM base classes. User has to use these base classes and create the required components. Because UVM base classes already has some implementation, you don't have to spend a lot of time developing the test bench. It's like simple example I'll give you. A simple analogy could be, we want to construct a house. You see, there is a concept called as prefabricated structures. So what we might mean by prefabricated structures is they will directly get the structure, one room structure, another room structure, another room structure, and they will just put together everything. You got the house. This is what UVM does. In UVM, already this is available. You just have to customize it for your requirement. What do you want here? What do you want to keep it here? What do you want to keep it here? That customization you want to keep. Let's say same thing. Let's say you talk about one more house, one more room. What customization you want? Like this, you have to customize. But these structures are already available. This is what we are calling as the base classes. Okay, base classes. This one base class, this another base class, this another base class, this another base class. Now comes the second part, where we develop things from scratch. That the way we do it in system Verilog. In system Verilog, what we do is we have to develop all these walls. We have to develop each of them individually. These structures are not available. We have to construct that, construct this, all these things. This is second approach. That is system Verilog. Now you may say, what is Verilog? Verilog also does the same thing. The problem with Verilog is Verilog doesn't have this concept of individual division. Just no rooms, everything is in one place. What Verilog does is everything is one place. So everything is mixed up into the same thing. So you will see that when you do everything in one place, it becomes very difficult to manage the house, that whole thing. Okay. Then you did the division. But when you are dividing, you are developing everything from scratch. That is where people figured out that, see, houses have a lot of things in common, right? Every house has a hall, every house has a kitchen, all those things they have observed. What they have done is they came up with a concept called as prefabricated structures. And then just by using those prefabricated structures, you develop your own house. That is what UVM does for us. Now, what is that as a verification engineer? When you are learning UVM, what is that you need to learn? You need to learn what all prefabricated structures are there. Okay, one for hall, one for kitchen, one for a dining room. Like that, you need to know that these many options I have. Then you should know how to use this prefabricated structure. What all functions are there? what all variables are there, how to use those things. Let's say if I take one more one more base class, how to use that base class, again how to use this base class. This is what you need to know. You understood how the things transition from Verilog to system Verilog to UVM. So this is about UVM, how UVM makes the test bench development easier. Now let us get back to the presentation and understand things. Okay. So what is UVM? UVM is Universal Verification Methodology. UVM stands for what? Universal Verification Methodology. What is mean by universal means? Globally, everyone has to follow. I mean, this is something that is suggested for everyone to follow this methodology to develop the verification environment. They are telling that use this methodology to develop everything. UVM is a open source methodology. UVM is nothing but it's a library files. UVM is nothing but library files. These are openly available. User can view the code and use the code without any licensing. See, there is one website called as Accelera. You go to Accelera UVM somewhere. See, you'll get this link. If you just click Accelera UVM, you'll get this link. We can download these things. See here, we can download this methodology. All this class library code, I can download this. When I download this, see down you can see it is UVM 1.2 .gz. Down if you see here wherever my cursor is there, when I go there you can see UVM 1.2 .tar.gz. So this is a version of UVM 1.2. So that means UVM itself was released in multiple revisions. UVM is released in multiple revisions. Like I can call UVM 1.1c, UVM 1.1d, UVM, then came 1.2, like that. It was released in various releases. So now you need to understand in the test bench you are working on which version of UVM is used. But given an option, we should go with UVM 1.2 version.
Just only this Accelera only provide these documents.
Yeah, Accelera is where you download it. Maybe if you go to Mentor Graphics and Cadence, they may also give you. But as a person who is if you want to directly download, you go to Accelera page and download it.
Okay.
It is developed in collaboration by Mentor, Synopsys, and Cadence. Maybe they have collectively called that forum as Accelera. Okay. UVM can be used with any of the simulation tools. Let's say you're working with Mentor Graphics tool, you're working with Synopsys tool or Cadence tool. Doesn't matter. UVM can be used with any of the tools. Why? UVM is nothing but SV only. UVM is no different. UVM is system Verilog only. So UVM is essentially system Verilog base classes only.
Hello.
Yeah.
Can UVM be used with open source tools as well?
Which tool? Please tell me.
I enrolled for the course. However, I have not so. For example, these mentors, these are for I think Verilog simulation tools, right? So for iVerilog or something.
You can't use because iVerilog doesn't support system Verilog.
Oh.
Anything that supports system Verilog, complete all constructs of system Verilog can be used to run UVM based codes.
Okay.
Okay. iVerilog doesn't support. If you ask that Xilinx ISC, right, that tool will be there. That also won't support UVM because that only supports Verilog only.
Okay. Secondly, just a general thing. I enrolled for the course. I did not get time to look. Today is Saturday, right? The thing is, I feel it's slightly overloaded. I'm not able to understand. I'm not feeling confident that I will be able to execute it. So this is demo. Is the full course easy? Like I can like once the course is done, it will be okay, right?
No. See, thing is, if you are looking for UVM training, you should be good with system Verilog. These are the UVM training prerequisites.
Oh, okay.
You should be system Verilog. How much good? If I give a simple design, like very simple design, a pattern detector, not even pattern detector, forget pattern detector, or a simple counter, 3-bit up counter,
Hmm.
should be able to develop complete SV based test bench.
Okay. Okay.
You should complete SV based test bench. If you are not confident about that, then you won't benefit out of UVM training, because in UVM training we don't start from scratch. We don't start from the basics. We start from
Oh,
with the assumption you are good with SV.
okay. So now I have not enrolled for SV. So I think I should brush up. I know SV, but when you say SV, is it the college level SV or the SV which you discussed now with this monitor, driver, scoreboard, and all?
All those things. Whatever I discussed, everything.
Okay. Okay. Okay.
So I told you, right, you should be able to develop this kind of test bench. Whatever I
Oh.
shown this, assuming that this is 3-bit up counter,
Hmm.
you should be able to develop the complete test bench for this.
Okay. 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 Yeah. Let me try. Okay. Yeah. Thank you.
Okay, if you are
I will
not
brush
able
up.
to develop test bench, then
Yeah.
please don't take UVM training. You won't benefit out of it. Okay.
But I already took. So it's 2 months, right?
2 months. Yeah. Then you have to go to system Verilog training.
Okay. Okay. Okay.
Okay.
Okay. Yeah.
Thank you. So this is about UVM basics. The first thing you need to understand is UVM is not a tool. UVM is not a tool. Not like it's a compiler. It's not a simulator or anything. It is a guidelines on how to do everything of test bench. It is a guide, a set of base classes and macros. These are collectively called as UVM. What is UVM? Guidelines on how to do everything of test bench. For example, whatever you want to do in test bench, the UVM will tell you how to do it. For example, I was talking about constructing a house. So I want to decide where to keep the one of the things. I mean, where to have the sit out area, let's say. Simple example. My guideline will tell me where that should be coming. So user don't have to really spend a lot of time to figure out where it should come and all that. So that is what UVM is about. That is guidelines. And also see, it is telling me where sit out area should be present. Should be present in house. It will also provide it also provides me with a sit out area prefabricated structure. So what it does is, it is giving me guidelines where sit out area should be present in the house. Next, it also gives me that prefabricated structure also. In system Verilog, you don't get both of them. In system Verilog, you have to make a decision yourself where sit out area should be present in the house as part of the house. Next, you have to develop this sit out area prefabricated structure, sit out area structure from scratch. That is where you spend a lot of time. Did you understood, everyone? So that is how UVM makes it easy to develop the test bench. Tell me which was easier. This approach is easier where someone is telling me what is the right place to keep the sit out area, and someone is already providing me prefabricated structure. That is one way. Second is option is what? User has to develop everything. In system Verilog, user has to make all decision and also develop from scratch, which is easier. The first approach is easier, right? So that is why we prefer this one. If at all there is an option, there is a flexibility. Okay. So here also, that is why industry is moving from system Verilog to UVM. Again, having said that, as I told you before, when the time is coming down from 4.5 months through to 3.5 months, we are not compromising on the verification quality. Even though we take less time in setting up test bench and completing the verification, less time in doing these things, we won't compromise on the verification quality. Understand, we will not be compromising on the verification quality. That is very important for us. So before learning UVM, you need to tell yourself that UVM is easy. Actually speaking, it's easy. Once one test bench you develop, you learn 80% of UVM you learn. Then same that all those concepts are applicable in every test bench. Now let's get back to the presentation. Let us now understand how UVM has evolved. Please read this once. I hope you have gone through it. So till 1990s, verification was done using Verilog since designs were simpler. With the design complexity increasing, Verilog was becoming bottleneck in the verification process. That is because Verilog was actually not meant for verification purpose. What is the problem with Verilog? It has got few constructs, very few constructs for test bench development. Then object-oriented programming based hardware verification languages evolved in late 1990s. So that is where we got new languages like Vera and Specmany. Actually, these were very famous during 2000 and 2010 timeframe. That is around 15 years back, 15 or even 20 years back. They were quite famous actually. System Verilog was not there at that time. I mean, it was just starting off. Then IEEE came up with a standard called IEEE 1800. That is called a System Verilog. Okay. Now, why EDA companies develop these tools, Vera and E languages? I mean, these are languages actually. Vera is like a one language like System Verilog. Specman E is like a one language like System Verilog. They developed their own languages because they wanted to promote their tools. See, if let's say Synopsys developed Vera. Synopsys developed Vera. Developed Vera language. Why? Because anyone who develops test bench using Vera will have to use VCS2 compulsorily. So hence they can sell the tool, right? That is how they developed tool out of their interest and out of industry interest. So these HPL based test benches have a lot of things in common across the test benches. That is where different evolutions happened. RVM, ERM, AVM, VMM, OVM, UVM. Finally, we are settled with UVM. The methodologies went through various stages, and finally, one methodology that we are adopting is universal verification methodology. It is nothing but it is a superset of all the methodologies. A lot of things taken from the E-reference methodology. I mean, actually, UVM takes a lot of things from E-reference methodology. This is about UVM. Next, let us understand why we need a methodology. I think we have already discussed some time back. Let's again quickly revise why we need methodology. Okay. As I have told you, some time back I have asked you, take few designs, USB controller, DMA controller, memory controller, and keyboard controller. Let's say we develop test bench for all these controllers. What is that you see is there are a lot of things common in all these test benches. You take any test bench, there are a lot of things common in them. So for every interface in the design, we need to develop BFM, generator, monitor, and coverage. For every interface, we need to develop sequences and transaction classes. The point is what? This test bench, what you see, doesn't really differ much. If I go from keyboard to SPI, SPI to some other DDR controller, this structure remains same. See, the functionality will change. Of course, the driver can't be same, generator can't be same, reference model can't be same, but there are a lot of things that are common. What methodology does is, methodology brings uniformity into the complete verification flow. That is the way verification engineer do the things. It brings the uniformity. What is the advantage of uniformity? Tell me. What is the advantage of having some uniformity? When a test bench is developed, using UVM. A lot of things are uniform. What is the advantage? Tell me.
Understanding will be easier.
Understanding will be easier because see what happens. A new team member joins into the project. He or she can immediately understand the test bench. He or she can immediately understand the test bench, what is present where, how each of them is connected. They can understand what component is present where, how they are connected to each other, how components are connected to each other, where test cases are developed, where a scoreboard is implemented. All those things, it won't take any time to understand because all the things are uniform. Means when someone develops a test bench using UVM, they have to follow some guidelines because everyone knows that these are the guidelines that are followed. For me, ramping up onto a new project is very easy. If I same thing, someone joins into system Verilog based test bench, let's say new team member joins into system Verilog based project. Things are not uniform. See, I could have developed in my own way. So it is difficult to figure out where the component might be present, how the component might be connected to each other, where the test cases are present. All those things are little difficult to understand. So for new team member to ramp up, it becomes difficult. This is one advantage. Second advantage is since everything is developed as per common methodology, one test bench components can be used in another test bench. Because since both of them are UVM test benches, I can take out this component, use it somewhere else without doing much changes. So these are all the benefits of UVM. Okay, everything user can think of. So what do you mean by uniformity? Everything user can think of in functional verification flow and test bench development. They're all, those guidelines are provided by UVM. So please read this, like I think you've gone through it. Test bench architecture definition, test bench component coding, test case coding, scenario development, printing various types of messages, deciding when to end the test, reporting the test case status, connecting components with each other, checking the design outputs. All these things I have listed only, I think 9 points here. Like this, if you start listing down, you will get another 20-30 points. UVM defines all these guidelines on how to do efficiently. UVM defines guidelines on, UVM provides guidelines, I would say. UVM provides guidelines on how to do all these things efficiently. So just that user has to follow that guidelines. User needs to follow those guidelines when they develop their test bench. Okay. Now, did you all understood why we need methodology? Next. So I will not get into this reference design right now because it unnecessarily complicates our thinking process. If you have understood why we need methodology, that is sufficient. This slide was meant for that. I would rather go on to do some test bench development directly. Now what we will do is, we will take one simple example and further let's see how to develop the test bench. We will take an example of a memory. We will develop the test bench for this, and while we are developing the test bench, we will understand various aspects of the UVM. So my point is, rather than going through a lot of theory and reading the things, it is better to get into an example, a simple example, memory, the one we have done in System Verilog training few weeks back. The same memory I'm going to take. Now what I'm going to do is, I'm going to set up the same test bench using SV and UVM. And we will understand how these test benches differ and how this UVM based test bench reduces the time taken. So while we do that, I will also go through the individual slides also. So the first thing we will do is, I'll have to copy the memory code. Where is the memory code present? This is my memory code. So I will create a directory called as memory test bench. I'll move this into memory test bench. Now in this is our design. This is our design. It is a simple memory which has got one interface like this. What I will do is, it is very similar to APP protocol. Similar to APP protocol. I will do some small changes to make it actually APP protocol only. Right read is nothing but the right. Address is what? The address. Write data is nothing but P write data. Read data is nothing but P read data. That's all. This is APP protocol for us. So what is that we have taken? Our design is our DUT is memory with APP. So what is APP protocol? Is everyone familiar with APP protocol? Is there anyone who is not familiar with APP?
Hello, yes, I am not. I'm sorry.
You are not familiar. Okay.
Hello.
Anyone else? Yeah. Anyone else?
Like, can you tell me very quickly, just a brief, yeah, what it is, yeah.
APP stands for Advanced Peripheral Bus Protocol. It is used for simple single write and single read. Means basically these are called as atomic write and atomic reads. It uses signals called as P address to issue the address, P write to tell whether we want to do write or read, P enable to tell that I'm doing a valid transaction, and it will issue the data, write data through PW data, and it will get the read data from the PR data. In response to that, it gets P radio. So there is It's a protocol like this, where you drive the P address, you tell P write telling that I want to perform a write, you select a slave. P selection signal will be there, that I haven't done so far. You can keep here if you want. You can keep one more signal called as P selection underscore I. Then you have to write P selection underscore I. So wherever you have used P enable, there you have to also use and P selection I equal to 1. In summary, you are driving P right, P selection equal to 1. Whenever you make P enable equal to 1, you are telling that your address is valid, you are issuing a valid write data. Then slave responds by giving P ready equal to 1. This is where the transaction completes. This is a timing diagram of APB write transaction. APB write transfer with no wait states. APB write transaction. So what is actually happening is my master is performing a write to address 1 with data 1 to the slave. So what it does, it issues the address, it tells that I want to perform a write, and it selects the slave, which slave, this slave it is targeting, it selects that slave by making selection equal to 1. And whenever it wants to do the transfer, it makes enable equal to 1. And at the time, slave says that I'm ready, and the write completes. Similarly, read also happens. This is right only. Okay, read is not there, but read also we can see. What in read, what we do is, instead of this going high, it will be low. It will be low. This won't be there. It will become 0 basically, indicating that I want to perform a read. And the data won't come from the master. Data will come from the slave on PR data. My slave will issue the data somewhere here. I hope you understood, Saran.
Yes, I understood a little bit. Yeah. So it's like a protocol for interface of memory, right? Like Ethernet and all.
Yes.
Like,
Yes.
yeah. But the
Not
thing
as
is, I
complex as
happened to work on this memory, but I didn't. Is all memories the same interface? I worked in
no.
something which is have no interface. I think like no standard interface. Can that happen?
Yes,
Or
it can
am I not
happen.
knowing it? Oh, okay.
No, it can happen. In this case, we are using
Oh.
memory with APB.
Okay.
Okay. Memory can also be with AXI interface. This could have been replaced with AXI also. This can be replaced with AHB also. This can be replaced with, sometime back I had some generic signals. That is also possible. It can be anything. In this case, we are using APB interface, because why we are taking APB interfaces? We are going to develop, we will develop APB UVC component. UVC stands for Universal Verification Component. And APB UVC is connected to memory, and by using that we'll check to check the memory behavior. Till this point, everyone able to follow? Any questions you have? No. Tell me, how does the test bench environment start with? Always. In system Verilog, when we develop the test bench, how did we start the test bench environment?
First we do test bench down. Top to down.
You have to develop the test case. In system Verilog test bench, what all things you code in top.sv? Tell me. DUT instantiation. First thing actually is okay. Clock and reset. and generate both. This is what we have done. Second thing is what? Physical interface, instantiation. Third thing is what? Duty instantiation, connection. And connection to the interface. And fourth, what did we do? Tell me.
Environment call.
Environment, new and run, start. Fifth is what?
Logic to end the simulation.
Logic to end the simulation. What else did we do other than this? What else did we do? I think mostly this is all what we have done, right? Sorry. Next thing is what we have done is put all common things into common class. Do you remember that common class? We had mem common in our Testbench. Something
Yes.
similar to that. Sixth thing is logic to end the simulation. Now what I'm going to do is I'm going to use the Testbench only. I don't want to develop everything from scratch. I'll use the Testbench only, and on top of that we'll do required updates. TB top. Let me copy exactly the same code. This is the code that we developed in System Verilog Testbench for memory verification. This line, do we need to change line number 9? Tell me.
No.
No, right? And I will save it as, I'll save it as tbtop.sv only. Do I need to change line number 9? No. Do I need to change line number 11 to 14 in UVM based Testbench? No, right? It won't be same. Now, the way you apply reset, you don't need to change. This need to be changed basically. Here comes a difference. This is where the difference comes. This line is where difference comes. In UVM, so what was our assumption in System Verilog? In System Verilog based Testbenches, our assumption was, so how was the System Verilog based Testbench architecture? System Verilog based Testbench architecture, how does it look like? Let's understand. You have top module.
Top module.
Below that, top environment class. We didn't use, what is that we didn't use? Tell me.
Programming block.
We avoided program because we thought that program is redundant now. Below top environment, what you have? Sub environment classes. Scoreboard, sorry, reference model, checker, and scoreboard. Then below sub environment we have, what do we have? DFM, generator, monitor, and coverage. Do you agree? This is how our System Verilog based Testbench architecture looks like. UVM based Testbenches, there is some variation. How they vary is, this top environment, before that comes something called as UVM root, also called as top. Similar to program block, actually similar to program block in System Verilog Testbench. Below UVM root, UVM test top will come, which is nothing but the test case user is running. Below that, all this thing will come. So what are we doing? We are keep adding 2 more hierarchies into the architecture, Testbench architecture. The top environment will be same. The sub environment will be replaced with what? What is that I told sometime back?
Agent.
Somewhere I told in the top. Sub environment will be replaced with what? Agent. So I'll call it as agent. Reference model will be replaced with what? Good. DFM will be replaced with what?
Driver.
Driver.
Generator will be replaced with what?
Sequencer.
Sequencer.
Sequencer. That's all. That's all. If my point is what is that I'm trying to tell you is, if you know how to develop system Verilog based test bench from scratch, it is no different. It is not going to be any different. So let us now do that activity. Let us now do that activity. First of all, please go through this and let me know if you have any questions. See, I know these are the new keywords. UVM root is new. UVM test stop is new. We will discuss all those things. Why that is required? You may ask, why not simple this only? You may ask one question, why not simply go with environment structure which is similar to system Verilog? So if they are adding these two elements in between, there is a reason. They have a reason why they are adding all these two elements. We'll discuss all those things. So this line will not be there. Environment will not come into the top module directly. Instead, what will come? We will have to do UVM root as top. Somewhere in the initial block, they will do top equal to new. Then top dot run test they have to call. Something like this we have to do. This is what we are supposed to do. Are you getting what I'm doing? See, this is what we exactly did for environment also, right? We instantiated environment. We are creating environment and we are running the environment. Now I'm telling that let's not do that. Let's not do that. Instead of that, you instantiate the root. Below top module, what hierarchy comes? Root hierarchy comes. Instantiate the root. You create the top and you call the top dot run test. Are you getting what I want to do? I am replacing environment with UVM root. In this context, I will introduce you to one concept called as source one. Do you see if I show you this code? If I show you this code, do you see any commonality? If I show you this code, take a look at this code. Do you see any commonality between both of them? We are instantiating UVM root. Here they are creating the root. Now what is get root, all that we'll discuss. Right now let's not get too much deep into it. They're creating the top module, creating the instance of top. Then here calling the top dot run test with the test name. Which test name they want to run, they're running with that one. Can I say that this code is almost similar to this code? Can I say that?
Yes.
Right. So point is, instead of doing all this, what we will do is we'll just create one initial begin end, call the method run test. That's sufficient. Then I don't need to have these things, this code. This is essentially doing all this activity for me. So whatever we wanted to do one thing, that is all taken care of. See, we wanted to do this one, instantiate root and call the run test. Call top.run test. That is what we wanted to do. That is happening now. When you call run test, it is doing all this activity for us. Now the question comes, where is that present? It is present in the file called as UVM global. Tell me, what do you understand from the term global? What do you think it is probably referring to? Can you tell me?
Outside of the class.
Common file.
It is there in the global scope. It is there in the global scope. Global scope means what? Outside every module and outside every class. It is present outside every module and outside every class. So because of that, we can call that without any hierarchies. See, I didn't use any hierarchy. I'm just calling it. The run test is not present anywhere in my code. In my tb-top.sv, it's not present. Just because it is present in the global file, I can call that run test directly. This line takes care of this part of the code.
That file we need to write uvm globals.svh file.
No need to write. Basically, what you have to do is, whenever you set up any UVM test bench, first thing you have to do is include UVM package.sv. There will be one UVM package. Whenever you download any UVM package, UVM code, you will get this file, UVM package.sv. That package itself has everything included in it. That package has everything included in it. The DPI packages, base class packages, DAP packages, TLM packages, component definition packages, sequence definition packages, TLM2 packages, register model packages. Everything is part of this package. So all you have to do is you have to tell that I want to use this package, include this package. Once you use a package, what is the next thing you have to do? You have to import the package. You're telling that I want to use all the definitions present in UVM package. These two lines are compulsory. Anytime you develop any UVM based test bench, these two lines are compulsory.
So if you call that directly, it will not use like system Verilog.
It won't work because how does it know the definition? See, okay, run test is fine, but where is run test present? Okay, this one. What is UVM root? Who is telling you the UVM root definition? Who is telling you UVM core service definition? That all those definitions are part of this package. That package has all these things. Somewhere inside this code, these definitions will be present. Did you understood what is happening? Okay. So this is the package. Now, do I need to do any changes in reset procedure? Tell me.
No, sir.
Not required. It's same. Whatever you do in system Verilog, here also it's same. So what is that I'm trying to do in all these exercises? To tell you that when you move from SV to UVM, things don't turn upside down. Things are very much same with some minimal updates which bring more convenience to us. See, whatever we did, it's a convenience. See, you don't have to do a lot of things. Just you write initial begin. This is sufficient. Initial run test is sufficient. No need to even use begin end because there's only one statement, initial run test. That's sufficient. You're telling what you're by writing this, you're telling that start running the test bench.
Sir, I have a question here. What is the difference between if we are including and importing? Without importing, when we require to import actually? Because sometimes we are including only, right?
Basically, whenever you write everything as a package, you have to import. Actually, for you, that will be covered on during the Tuesday session. The packages will be covered during the Tuesday system relaxation.
Okay.
The concept of package, then you will understand. So whenever there is a package, end package, package and end package, you have to write import.
Okay.
So this is about till this point. Now I think this is not required. Do I need to change line number 42? Tell me. When we move to UVM test bench.
No, sir.
Not required. So this is where, so this also not required. Here things will differ. System Verilog, we define our own mem common database. In case of UVM, provides a UVM configuration database. What is that? It is
UVM
called as
configuration database.
DB, where we will keep this definition. Keep above interface handle. Please read that statement, what I gave. In System Verilog, we define our own mem common database into which we are keeping the physical interface handle. In UVM, you don't have to do that. You don't have to define mem common itself. Mem common won't be there in System Verilog. Ideally, you should not use it. Then how do we do it? User has to use UVM config database. Config database comes from the language. So you have to write something like UVM config database. What is that you are trying to set into it? See, config database, I'm using it. Later I will explain you. Right now, I'm using it, okay? Because I wanted to show you how easy it is to develop a test bench in UVM. With a knowledge of System Verilog, developing UVM test bench is also easier. So this line, equivalent of this line, I'm writing now. Virtual. What is that you're trying to put? You're putting virtual APB interface. Virtual APB interface. Set. You're setting a value into the database. Setting a value into the database. That value is UVM root get. Okay, this specific part, please just understand right now, accept right now. We will discuss as we go forward. I'll explain you all these concepts in more detail. Star, virtual interface, and PIF. So here, similar to what you have done here, in the same thing, we are setting one physical interface into the database. We are setting something physical interface into the database. We are giving a name called as VIF. That database is called as config.db. The database name is called as config.db. And what is the data type of the database? That element we are creating, virtual APB interface. So this line won't be there. I think we are getting more and more complex. Let's not. For those who are new to all these concepts, I mean, I'm sure this is new to every one of you. Please be assured that I'll be talking about all these things in detail, in depth. What is that I'm trying to do is, I'm trying to give you a bigger level picture right now. I'm trying to give you a bigger level picture. Eventually, you'll understand everything. It's not as complex as it looks to be for you. Actually, this statement looks complex right now, but it's not that complex. What we are doing is, we are setting physical interface into the database. We are giving a name to it. And I'm telling where all it should be applicable. This concept tells who all will be able to see this variable. I mean, I don't want everyone to see. I'm telling who all should be able to see that. By using these two, I'm telling that. Right now, that much you understand. Now, tell me, does this change when you go from System Verilog to UVM?
No.
No.
It changes, right? DUT instantiation will remain same. Next. In UVM, you don't have to do this. What is this logic? Please tell me, what is this code? A logic to end the simulation. Here we are writing a logic to end the simulation where we are telling when the transaction count reaches the total transaction driven, then we are ending the simulation. UVM has built-in logic called as objections. It is called as objections, which will tell when to end the simulation. Automatically, you don't need this code at all actually. UVM has a built-in logic called as objections, which will tell when to end the simulation. So now if you look back, if you look at everything, tab new, TB top, lot of things are common. What are the first difference? Tell me, when I moved from SP to UVM, starting from line number 1 onwards, which is the things which I have added? Can you tell me which line numbers I have added in this code?
It will include UVM package.
This thing, this is first thing I have done. This is common in any, you write down now, please write down. If you have a notes or in your laptop, open a notepad and write down. Line number 9 and 10 must be done in every UVM test bench. You take any UVM test bench, these two lines must be done. What these two lines does is, they include all these definitions. See, my UVM package has all these files. They all get included into my test bench environment now because I have done that. And I'm importing all those things into my test bench definition. My current environment, I'm importing all the things that are part of the UVM package. Next. Can you tell me, are there any changes here?
No, sir.
No. Are there any changes in reset input? Same, right? When we have to reset up inputs, it's same in SV and UVM. Again, which line number is different after this
8.
one? 28. You just have to call initial run test. If you to make it look better, just write in two different lines. Now, is there any difference in this code?
No.
No.
I think the 34 line number.
34. Yeah, this is not required. Actually speaking, this is not required. UVM does it automatically. This is also not required actually. Yeah. Next. Did we do any change in line number 43?
No, sir.
Okay. In here we did the change. Instead of putting into our own database, we are putting into UVM specific database. That is UVM config DB. What we are doing is we are creating one entry in the UVM config database. That entry is physical interface, so that anyone can access that physical interface from anywhere. That was the intention with which we did this, right? You remember earlier? Now also we are doing the same thing. Next. If you look back here again, after root, what is coming? Please tell me. After UVM root, what is the next in the hierarchy?
UVM desktop.
UVM desktop. Basically, user has to define the test case. User has to define the test case. I will do this and we will take a break. My point is I won't get too much deep into the complete leaf level. So we have to create something called as test case.sv. Test case.sv. So the test case in UVM is developed as class. Whatever test you want to develop. Memory, write, read, test. What is this test is for? Writing to that memory and reading from the memory. Extends. UVM test end class. See, I'm going as per this hierarchy. Top module is done. Then I have UVM root. Below that, I'm keeping UVM test top. You may be thinking, what is you are right? You are telling UVM test top, but you're writing memory write read. Actually, mem write read gets instantiated as UVM test underscore top. So hence we use the term UVM test top. Develop it as a name mem write read, but when it gets instantiated, the instantiation name will be UVM underscore test underscore top. Here comes one primary difference. That is, in system Verilog, test case is a scenario. Test case is a stimulus implemented inside generator. In UVM, test case is a component. Test case is a component implemented as a separate component file or a component. Understand the very important difference here. In system Verilog, test case is a stimulus implemented inside generator. Whereas in UVM, test case is a component implemented as a separate file. That is what, if you see, I'm doing that. I'm implementing as a separate file, testcase.sv. I told you that in UVM, whatever you develop, you have to always extend from the base class. Now, why we are extending is whatever common things in UVM test will become part of mem write read test. Whatever common things that are there in UVM underscore test will become part of mem write read test because of the concept of inheritance. I hope you understood this. Now, what is that below test will come? Tell me, below test top, what is present as per the hierarchy? Environment. So here you have to instantiate mem environment as env. Here you have to keep mem environment. In system Verilog, what we used to do? We would have function new, end function. Here we would do env equal to new. Then we will have task run, end task. I will call env.run. Do you agree with this? This is how we would do in system Verilog. Right? We are extending it from UVM test. We will instantiate mem environment. We will create the environment and we will run the environment. This is how we would do it in system Verilog. How it differs in UVM is the function new definition gets changed here. When you go to UVM, there comes a concept called as string. So first thing is UVM component name, string, UVM component parent, string name. These two hierarchies will come. Here you have to call something called as super.new name comma parent. Actually speaking, this order will be different. First string name will come, then UVM component parent. Say I'm doing the same thing as system Verilog. Only thing I'm telling is my hierarchy will have my argument new will have two arguments now, name and parent. On that we call super.new name comma parent. Then I have something called as function void build phase UVM face end function. Here we create environment equal to new. We are creating the environment. We are creating the environment. This run becomes run phase. Actually speaking, it is not required. Only one more difference we have to do is we have to register it to the factory. UVM component utils mem write read test. If you go back to the notes that I have written, top module, below that you have UVM root. That is nothing but TB top. Below that I'm calling run test, which will take care of this part of the thing. Below that root, I have test case. So here I'm defining the test case. And as per our notes, below test case, what is present? Top environment is present. So that is what I'm defining here. Below my test, I'm instantiating environment. I am creating the environment. Now the question comes, we removed this part of the code, right? You see, I removed task run, end task. We are supposed to call mem.run. This is what we are supposed to do. Actually, UVM does this automatically. User don't need to do it. Sorry, tell me. Yeah, actually env.run. User don't need to do this. UVM does it automatically. So hence I don't need this code. Now I will be doing only memory environment coding and I'll stop hierarchy, because otherwise what will happen is I'll have to develop everything till scratch. The leaf component, that is driver, sequencer, monitor coverage. I won't do that because that would unnecessarily complicate our session. I'm just trying to give you a basic perspective of how do we approach UVM based test bench development. So the next thing would be mem environment.sp. This would be the last thing. Okay, I won't go deep into it. Then I will start off with very basics. Mem environment extends UVM environment. Everything has to be extended from a base class. You need to register it to the factory. We call it as mem environment. This is called as factory registration. Then we have to keep this definition. That's all. This has completed my hierarchy till memory environment. Now to run this environment, what do? We include all the files, right? Include mem environment.sp, include test case.sp. I can run this now. Now what is the test we have developed? Memory write read test, right? So to run the test, what I do is, as part of the run test argument, I have to pass mem write read test. So I'm running memory write read test. That's what I'm indicating here. Go here. How to create run.do. I mean, how to create a run script. What all steps will be there in run file? Tell me, what is the first step we do in the simulation flow?
VLOG.
We do compilation, right? So the compilation, we do vlog tbtop.sp. Now my source file, if you see, my source file is present in this hierarchy. These files are present somewhere else and I'm using them. So that means I need to include this directory so that I can get this definition. I have to write plus include directory plus dot 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 UVM 1.2 source. Let's see what is that. So, no, source underscore 1.2 src underscore 1.2. Once compilation is done, what is the next thing I have to do?
Elaboration.
Elaboration. So how do you do elaboration? vsim tbtop. Then what do you do? Add wave. Right now I don't have anything to add wave. Then simulation. I have to do run hyphen. So I can go and say do run dot do. Line number 10, there is a problem. If you go to line number 10, there is a problem. Test case dot sv. So when I do new, I need to pass some arguments. Whenever you call new in system in UVM, you have to pass two arguments. One is the name, one is the parent. That I was missing. Now I have added them. Memory interface and memory we are using but haven't included. So what I will do is I will get those from this project. Memory and memory interface. Memory I have, memory interface I have to include. So what I will do is I'll go to the TB top. Here I have to include memory.v and mem interface.sv. I'm including these two files. Once I have done it, now I can run this.
Sir, in that memory we change the signal name, all those things, right?
That we have taken care. Yeah, let's do that change also. Memory.v. Somewhere I might have used clock only. Yeah, I'll have to change clock. Here, reset, change it to p reset.
This level also we need to change.
What I have to do? Line number 56, we have to do some changes. In line number 56 in TB top. Yeah, this thing need to be changed to all need to be changed to P first thing. P clock, P reset, P address, P write data. This will become P write underscore I. This will become P enable underscore I. Along with that, we have P selection underscore I. So I need to have P selection underscore I. I will call it as P enable underscore I. As per these things, my definition also need to change. Mem interface definition need to be changed. Logic P selection I, P enable I. I think valid is not there. Similar to that, it will become enable I. So the compilation is clean. Now the elaboration is going on. Only one signal is a problem. Line number 29. It should be P enable I. APB interface. Okay, it's not APB, MEM interface. Okay, there is some DPI error we get. That only will resolve and we'll stop this part of the development here. So what is that we have to do is, whenever we do this during elaboration, we have to give some svlib option. Whenever we run in QuestaSim, we have to give some svlib option. What I will do is, for that I will pick it from one of my previous projects, async 54 UVM, async 54 Testbench sim run run.do. So I have to pick this additional path. So I have to take copy this. Now if I run it, I should not get this error.
So why that DPI is required?
Actually, the UVM source code is not directly compatible with QuestaSim. So there is some DPI mapping is there in this file. That mapping needs to be included for this to work.
Usually this DPI means we can use the C, C++ files, right? Like that's the purpose of the DPI, right?
Yeah. $64 QuestaSim 64 10.6b. We have to do some trials. I will do that. Actually,
Sure,
what
that
we
is
have to do.
0.1c, right? But we are using 1.
No, that compatibility we have to take. Yeah, we'll do that. Cannot access. Wait, why it cannot access? DPI cannot access. 64 10.6b. 64.6b. It is same, right? Wait.
So the system is 64. It is Windows 64-bit.
Okay, simulation has completed. So basically, every time you use one of these QuestaSim versions, you have to use this SVLib path. Just go through this ones. So we were able to run. Now what we will do is, we'll just try to quickly summarize what we have done and what we are going to do further. We took a simple memory test bench from system Verilog and understood at top level what changes are required to port it to UVM based test bench. Okay, when we start the next session, we are not going to continue with memory TB. I believe that will be quite complex for you to start off directly with memory test bench. Even now I'm thinking I have probably done a wrong decision to start off, because I haven't explained to you what is config DB and all that. We are getting deep into it, so you may not have really understood. So that is where I will stop this portion of memory test bench development here. We'll now move on to the basic concepts of UVM. Okay. When we move to the basic concepts, there I will explain whatever the new topics we came across. So what are the new things we came across? Let's see. The new keywords that we heard. UVM keywords. What is meant by UVM package.sv? Why we are doing import UVM package? Then we came across some term called as UVM root. Then we came across a term called as UVM test underscore top. Then what other terms we came across? Then we used UVM component utils. Then what else did we get? Factory. Then UVM config DB. So we'll discuss about all these terms as we go forward. Let us take a break for 15 minutes. Once we meet after the break, we'll continue with the further session. Okay, we'll meet in 15 minutes. Hello everyone, we will start the session now. So now what we will do is, we will start from the basics. We will try to correlate whatever we are going to go through with the UVM test bench environment, memory test bench environment we have understood. So the first thing, when we start off with UVM environment, we need to understand that UVM is not a tool, it is not a compiler. It is a methodology developed on top of system Verilog. It is a methodology developed on top of system Verilog. So UVM is essentially system Verilog only. UVM is essentially what? System Verilog only. What does UVM consist of? It consists of lot of base classes, lot of macros, and multiple utility base classes, something called as factory, something called as configuration database, resource database, etc. This is all collectively we are calling as the UVM. And it is also guidelines on how to do each aspect of the test bench coding, like how to code a test case, how to write test bench components, how to connect test bench components, how to come up with test bench architecture, how to code test cases and sequences, how to check test case passing status, how to display the messages, everything, anything you want to do in the UVM, anything you want to do in the test bench, the UVM provides us with the guidelines. For example, when we did our memory test bench, we discussed that the run test should be called here. This is a guideline provided by UVM. So this is a guideline provided by UVM. Okay, next. Here, what are we doing in this line? Tell me. We are adding PAF into the UVM config database. This is also a guideline provided by UVM. Means it tells us that whenever you define any physical interface, you add that data, you add that physical interface into the config database. So this guideline need to be followed. Anytime anyone is developing the UVM based test bench, they need to do this. So these guidelines is what we are collectively calling as these base classes plus macros plus guidelines is collectively what we call as UVM. Now, the majority of things in UVM are implemented as base classes. Whatever we learn in UVM, everything, whatever we do in UVM, everything is implemented as base classes. Like printing messages is done using classes. Event is implemented using UVM event class. Test bench components are developed using classes. That means everything in UVM is a class. Anything we do in UVM is a class. For example, in system Verilog, how do you print the messages? Tell me, what is that we use to print a message?
Print and display the packets. Yes,
We use dollar display something, whatever, sample message, right? The same thing in UVM. We don't prefer using dollar display. UVM provides with a base class called as UVM report object class. Is used to print the messages. So in system Verilog, we had a method called as dollar display. In UVM, we have something called as UVM report object class, which is used to print the messages. Now, you may be thinking, are we complicating the things? See, it was very simple in system Verilog, just call dollar display. When you go here, you are using a class, using that class, you are printing the messages. Actually, even though it is little difficult, it gives a lot of flexibility. Okay, message printing. It gives a lot of flexibility in printing of messages. Any questions so far? So you need to understand that everything in UVM is a classes. For example, in system Verilog, we use event. It's a E. Event is a one type of data type. In UVM, same thing becomes UVM event class. So UVM event is a base class in UVM. So that means in UVM, everything is a base class. I would say most of the things. Most of the things. Okay. So in that context, we need to learn some basic concepts of object-oriented programming. I won't go deep into it. Just I want to tell you that object-oriented programming consists of 6 concepts totally. What are the 3 things we have already been discussing? What is the 3 things that makes up object-oriented programming?
Encapsulation,
Polymorphism and inheritance.
Encapsulation,
inheritance,
inheritance,
polymorphism.
polymorphism. Along with that, static concept of static properties and static methods. Static properties and static methods, and the concept of abstract classes is what we will collectively call as object-oriented programming. I mean, though we are used to these things, going forward, we can also include it and call everything as a object-oriented programming. So in summary, UVM is all about these all concepts are effectively used to create UVM package, which makes UVM very efficient actually. Okay. Going forward, we'll discuss how these UVM packages will be useful. Okay, one more thing I missed is the important concept called as parameterized classes. Parameterized class. Let us now talk about UVM base classes. Then we can move on to other aspects. First, let's understand UVM base classes. What is meant by UVM base classes? These are the classes implemented as part of UVM code, UVM library. If you go to this package, see SRC 1.2. This SRC is 1.1 version. This is 1.2 version. In this, all these directories are there. This is something which I have downloaded from Accelera. This SRC 1.2 is downloaded from Accelera. In this, I have various components, the base directory, components, DAP, deprecated, DPI, macros, everything is there. If you go to the base, you can see many definitions here. Barrier, base class, bottom-up phase, callback, various things are there. Similarly, if I go to components, COMPS means what? Components. You can see some definitions like agent definition, driver definition, environment definition, monitor definition, push driver definition, scoreboard definition, subscriber definition, all the definitions are there. If I open this definition, I can see the class UVM driver. So these classes are all defined in these files. This is something we download from the Accelera website. And all these definitions, all these things are finally included into UVM package. So if you see, this UVM package has everything included. If you go to one of these files, so everything is included in it. Okay. All the files are included in it. So if someone asks you what is UVM package, is essentially I'll tell you. Go here, find dot name star outcome. Wait. Name. These all files actually. So all dot text. All dot text. So how many things are there? 171 are there totally. Collectively, UVM is all about these 170 files. Are you getting the thing? Collectively, everything together is 170 files. See, I'm including the directories also. If I have to exclude directories, star.svh. 143 files totally. These 143 files is what we are collectively calling as UVM libraries. These 143 files are called as UVM libraries. Somewhere in these files, UVM driver will be present. Somewhere in these files, UVM driver will be present. Line number 51. So if you go to this file, you will get the driver definition. Somewhere in this file, UVM agent will be present. This is agent definition. Somewhere here, UVM sequencer will be present. See here, GF, you go into that file. So what is happening is, what is that we are seeing is, all these definitions are already provided by UVM for us. So when we develop something, if you see in our case, when we developed memory environment, we used UVM environment. So when I use UVM environment, what happens is, this UVM environment is part of components. So if I go to UVM environment, all this functionality, whatever is there here, also becomes part of my memory environment. So it effectively reduces my coding effort. Because I'm extending it from here, it reduces my coding effort. Did everyone understood what is the concept of UVM library? When we say UVM library, what is UVM library? So UVM library is totally 143 files. Each file having some class or some macro definition. Each file having what? Having some class or some macro definitions. All these files are finally put into what? All these files are finally included in which file? One top file. What is the top file? Can someone tell me?
UVM package.
What is the top file where everything is included into?
UVM top.
UVM package.sv. Understood, right? No, it's not root. I told, right? Everything is included into this UVM package. So here you are including everything. So that is the package. The basic concept of packages, anytime you use any package, you have to tell what all things you want to use from the package. The basic concept of packages is, SP packages is, anytime we want to use package, we need to tell what packages, what all things inside package to use. Here what we are telling is, in our environment, what we are telling is, I want to use everything. Star means what? I want to use all definitions present in UVM package. All definitions. Use all means star. For example, if I take the same thing instead of star, if I write UVM driver, it won't work. It won't work. Why it won't work is because you are telling that I only want driver. I only want to take driver definition. You are not getting UV environment from the package. Now when I change the same thing to star, you are getting everything. So everything comes. Now you see it's going through. I only did this small change here. Something. It is running a test memory write read test and simulation is ending. So it is telling that I'm running memory write read test. Okay. That's a different thing. Now let's get back to the point. Coming back to this.
So this package, it should always download from Auxiliary, or
Did you all understood what is UVM packages is about? All the base classes in this, all these base classes. Now let's also get how many base classes are there. Totally in UVM, how many base classes are also there? Let's get it. That also you can do easily. grep -ir class UVM dot. Totally 525 base classes are there. UVM has totally 525 base classes. What am I doing in this case is I am searching for anything that starts with class and the name is starting with UVM. So class UVM. So totally I have 525 such elements. So this number is not really important for us because we won't use all those 525. We are only interested in few of them, that's all. But I'm just showing you how to understand, how to analyze this package. Next, how to understand the base class hierarchy. UVM base classes are understood as, what does this relation indicate? Can you tell me?
that is inherited.
Inheritance relation. This is inheritance relation. So which is among this one, which is the base class? Can you tell me who is the base class? Which component is the base class?
UVM object.
UVM object is the base class. Report object is the derived class. So this is the base class, this is derived class. Now if you see, if you take one component called as UVM driver, it is actually inherited from UVM component. UVM component is inherited from report object. UVM report object is inherited from UVM object. Do you see that relation? Driver is inherited from component, component from report object from object. What is the benefit of this concept is that whatever they want to share for complete environment, complete all the classes, they keep it here. So even see there is a relation here. Because of this inheritance relation, these are part of this transaction class. This copy, clone, print, they are part of transaction class. These methods are also part of driver class. These methods are also part of monitor class. These methods are also part of scoreboard class. Do you agree with that? Because of this inheritance relation. So the benefit is they have developed the hierarchy in such a way that they don't have to code this everywhere, because they have used this as a base class, UVM object as a base class for everything. Everything you see here, everything you see here, everything you see there will have all these methods. Do you agree with that? Because everything is finally inherited from there only. See, this is related here, this is related here, this is related here. That means, can I say that my scoreboard will have copy method? Is it correct to say that?
Yeah.
Yes.
Please say yes or no. If you're not able to follow, you can say. So because of the inheritance relation, all these methods will be part of every class you see here. That is the first thing. Okay. The benefit is why they are doing that way is, if I don't keep it here, everywhere I have to write all those methods, copy, clone, compare, all those methods everywhere. By doing this inheritance, they're able to reduce that effort. Next, wherever all these components you see here now, all these components will have these methods plus these methods. Why? Because they are all finally inherited from report object. That means UVM subscriber will have the UVM report method. UVM environment will have UVM report method due to the inheritance relation. Okay, I hope you got a basic idea about how they have organized the base class hierarchy. They have organized in such a way that they have reduced their coding effort. See, whatever is common to everything, they have kept it in the base class, most basic class. Whatever is next level, they have kept next level of methods. Whatever is next level, they have kept next level of method. That means monitor will have all these methods plus these methods plus these methods. Even scoreboard will have, because finally they are all inherited like this, right? They're all related through this inheritance.
Reddy sir. Hello.
Base classes you see here can be
Hello.
divided into 7 categories. The base classes used for creating the test bench components. See, these are all used for creating test bench component. Like UVM driver will be used to create test bench component, UVM monitor, UVM scoreboard, UVM agent, UVM sequencer, UVM test, UVM environment. These are all used for creating the test bench components. Next, what is the next category? Let's see. The next category, the one which are used for connecting test bench components. One is for creating test bench component. Second category is for what? Connecting the test bench component. The third category is for creating the test scenario. The third category is for what? Creating the test scenario, like creating the transactions. So these are those things. This is for creating the scenario. This is for connecting the components. This is for creating the test bench components. This is for creating the test bench components. The fourth category is reporting the messages, reporting of messages. Reporting of messages. Okay. That is, for that we use report object and report handler. Reporting messages we use, this is the fourth category. Next. Fifth is called as utility and databases. Utility classes and database classes. They're called as UVM factory, resource database, config database, etc. Sixth is synchronization of test bench processes, that is UVM event and UVM barrier. Seventh is register model implementation classes. UVM, any UVM specific component or macro always starts with UVM underscore. It is UVM. Anytime anything starts with UVM underscore, for example, this is starting with UVM underscore. It is starting with UVM underscore. It is starting with UVM underscore. That's the indication that it is a UVM library provided definition. It means what? It is a UVM library provided definition. This is also UVM library provided definition. Everything is a UVM library provided definition because it starts with UVM underscore. What all methods are there in UVM sequence by default? So if you go through this diagram, if I ask you what all methods are there in UVM sequence, see somewhere here UVM sequence is present. This will have all the methods of this because of this inheritance relation. If there are any methods coming from transaction, they will also be there here. If there are any methods in sequence item, they will also be there. So in summary, my sequence will have at least these methods plus the body method. Copy, clone, compare, pack, unpack, body added in UVM sequence. All these are virtual empty methods. User needs to update them. We'll discuss about this concept later. Now, if I ask you one question, in the sequence, will there be build method? Build is present here. Will that method be present in UVM sequence? Can you tell me?
No.
It won't be present because this is a different hierarchy. This is a different hierarchy. So this will not reflect here. Now, the next question.
One question is, what is UVM
Will
root here?
monitor have body method? Body is present here. Will monitor have body method?
No, sir.
No, right? Because it becomes a different hierarchy. This becomes a different hierarchy. Now, the next question. Will driver have print method?
Yes.
Yes, because it is present in the base class. It will come here, it will come here, it will become part of this. So hence it will be present. So this concept you need to understand what methods are present, what methods are not present. So this is about base classes. Okay. Now let us get into some questions. So with this we will stop. I will give you some, we'll do this revision in the next session. Oh yeah, now you can speak. I was in mute.
Sir, one question there. What is that UVM root? What we discussed in the diagram?
We'll discuss. We'll discuss. Okay. What is UVM root is? Tree root. Tell me, what is tree root? What is the importance of a root for a tree? Tell me. For a tree, what is the importance of a root?
It will hold the entire structure and it will provide the entire root
This
tree.
is where tree starts growing from. Right? And holds the entire structure, as you said. Same thing is with UVM root also. UVM root this is where entire UVM test bench structure starts from. So generally UVM root won't be is not part of this diagram. UVM root doesn't fit in anywhere here. I mean, I can't tell that UVM root will come here like that. It won't be part of this structure. It is not part of this diagram you see. It's different. Finally, what you do is test is instantiated into root. Test is, if at all I have to show you, that diagram, I have to write a UVM root here. I have to write a diamond here like this. Then I have to do this. What is diamond means? It is instantiated into the root. That I have to show. If at all I have to put UVM root in this architecture. Okay. I hope this is clear. Any other questions you have?
So this UVM package we need to download from that website, or automatically tool will provide it.
No, we have to download it. There may be some tools may support. In any case, the best thing is to download and use it.
Okay, we need to keep inside somewhere in the inside that.
There are 35. Question is whether to download UVM or use it from tool directly. You have to search. See, what I have to do is in my package, I will see if anywhere UVM is present. Here there is no source code. Here there is no source code. I have to search. If there is any source code, I can use it. If I don't have a source code, then I have to download and use it. At least I don't see any source code in this path, so hence I'm downloading and using it. It is preferred to download and use it. Okay. I will show you now. Another 2 minutes I'll take how to set up a simplest UVM test bench. How to set up a very simple UVM test bench. So what we will do is first thing you have to do is create top.sv. It's a text file. By default, text file gets created. You open it, you call it as top.sv. The first thing you have to do is hash include UVM package.sv. Then you have to write import UVM package star module top in module initial run test. Whatever test you want to run, let's say sample test I want to run, for example. You can define sample test here itself. Class sample test extends UVM test end class, register it to the factory, component utils. What is registering I will discuss as we go forward. Sample test. You need to define function new, string name, UVM component parent, and function. Super.new name comma parent. Okay. Then I will just do one thing to show you the structure. In function void build phase that's all. I can run this. To run this, I copy this run.do here itself. Change it. This will become top.sp. It will become
Sir, we
top.
need the macro file, macro.sh.
Sorry, tell me.
We need that macro file .sh, whatever used before that.
No, it's not required because it's already part of UVM package.
Okay.
That's already part of Mac. This one. There is only print topology. Okay. Print topology. Wait.
14 phase.
Sorry, please tell me.
Elaboration phase, sir. PHS.
Phase. What is the error I am getting? Fail to find print topology. Wait. Instead of that, I will use UVM info. I'll explain this concept. Right now, it's okay. UVM top. Okay. Okay, this is the simplest way of setting up a UVM test bench. I mean, see what we have done in this case. We have defined a module top. In the initial, we are calling the run test. The sample test is defined here. This is the sample test class definition. This is the test case definition. We are registering it to the factory. Function new definition. Then build phase. What is build phase? What is end of elaboration phase is something we'll discuss in the next session. So what is the specialty here is I didn't call build phase, I didn't call end of elaboration phase. They're automatically getting called. See, sample test build phase is getting called, my hierarchy is getting printed. See, this print topology means print the test bench structure. So here the structure is getting printed because you call the method print topology. So these phases are getting called automatically. These functions are getting automatically because you call the method run test. Just because I call the method run test, these functions are getting called automatically. So these are some advantages of UVM. We'll discuss more of these things in the next session. So with this, we will stop the session. Do you have any questions before we end?
Sir, one question, like this constraints and randomization will be same as SV, right? Or anything we need to tweak in UVM?
Actually, not, all those things won't change. Everything will be same. You will understand that porting SV test bench to UVM test bench is only 2-3 hours effort. A lot of things, whatever you have done for constraints and randomization in system Verilog will remain same in UVM. Any other questions? In fact, when I was doing this memory test bench, you remember I was doing this memory test bench. Another 15 minutes, if you had spent another 15 minutes or maybe half an hour, we would have completely ported that SV test bench to UVM test bench. Okay, but just because I didn't want to complicate the session by doing too many things advanced, I have stopped. Otherwise, it doesn't take much time for us to port system Verilog test bench. Now, to answer your question specifically, the constraints and randomization will not differ between SV and UVM. They will be same exactly.
So when will be the next session? Tomorrow or next?
No, tomorrow won't be there. Sunday will be off.
Okay.
I will publish the schedule. Yeah.
Oh, okay.
Any other questions? We will let you know. We'll send you the mail with the schedule.
Okay.
Fine. We'll end the session here. Thank you, everyone.